students. So this is Mr. Manjunath. So today I have to discuss about mathematics 4 means M4 classes. The concept is conformal transformations. So first you have to take a complex number. No? So what is meant by complex number? So then z is equals to x plus iy. So z is equals to x plus iy. So x is the real parts of the complex number and y is the imaginary parts of the complex number. Then I is equals to square root of minus 1. So therefore z is equals to x plus iy is the complex number. So then definition of the conformal transformations. No? So definitions. Consider a complex valued functions. You have to take w is equals to f of z. Footing z is equals to x plus iy. Okay. So w is equals to f of z. So this is the polar form u of x comma y plus I v of x comma y. Okay. So complex quantities of z is equals to z of x comma y and w is equals to w of u comma v. Okay. So in this plane of z, this is the main transformed mapped into the curve c dash under the transformation w is equals to f of z. So then you have to take some graphical notations. Z plane and w plane, the coordinates of x and y axis you have to take. Then here also w is equals to w plane, the coordinates of u and y axis respectively. Okay. Then you have to take property. If w is equals to f of z is an analytic functions of z in a region of the z plane, then w is equals to f of z conformal at all points of the region where f dash of z is not equals to 0. Okay. So next discussion of conformal transformations. Given the transformation w is equals to f of z, we put z is equals to x plus iy or z is equals to r into e raised to I theta. Okay, I theta. So we obtain two given u and v as functions of x and y or r and theta. We have to calculate image in a w plane, okay, corresponding to the given curve in the z plane. Imagine in the w plane. So then take a problems. Discussion of w is equals to z square. Let us consider w is equals to z square. No, let us consider w is equals to z square. So take a u plus iv. So what is u plus iv? So x plus iy to the whole square. So or u plus iv is equals to x square minus y square plus I into 2 of xy. So then separating real and imaginary parts, we get u is equals to x square minus y square and v is equals to 2xy. Okay. First you have to take case 1. Let us consider x is equals to c1 comma c1 is any constant. The set of equations 1 becomes u is equals to c1 square minus y square, v is equals to 2c1 y. Now y is equals to v by 2c1 and substituting this in u, we get u is equals to c1 square minus v square by 4c1 square. Okay, 4c1 square. So is equals to c1 square minus u or v square is equals to minus 4c square of u minus c1 square. Okay. This also transformed into the same parabola. Similarly, you have to take case 2. This also similar terms of, let us consider y is equals to c2. C2 is of any constant. Okay. So the set of equations 1 becomes u is equals to x square minus c2 square. So therefore v is equals to 2x c2. Okay, 2x c2. So also the line, what is that? Also the line y is equals to minus c2. Okay, y is equals to minus c2. This is called the transformed into the same parabola. So here also two parabolas of z plane and w plane. Okay, w plane simply have to draw. Similarly take case 3. Case 3 is also some of radius of the circle. So here also z plane and w plane, here also z plane and w plane. Next, related problems. Question 1. Find the image in the w plane corresponding to the straight lines x is equals to c1 and x is equals to c2, y is equals to k1 and y is equals to k2 under the transformation w is equals to z square. Indicate the region with sketches. Take by using case 1 and case 2, by using case 1 and case 2. Okay, so what is that? Parabola corresponding to x is equals to c1 and x is equals to c2 and y is equals to kn, similarly y is equals to k2 are respectively the pairs v square is equals to minus 4c1 square of u minus c1 square, v square is equals to minus 4c2 square of u minus c2 square. Okay, here also z plane, you have to take z plane and w plane. Draw the diagrams. Okay, and similar type of questions you have to take w is equals to z square. Here also similar method is there, by using similar method only. Okay, v square w is equals to z square, that is a u plus iv is equals to x plus iy to the whole square is equals to x square minus y square plus I into 2xy. So take w is equal u is equals to separating real and imaginary parts, u is equals to x square minus y square and v is equals to 2xy, v is equals to 2xy. Consider x is equals to 1, becomes u is equals to, take v square is equals to 4 of 1 plus u. This is also parabola in the w plane with vertex. Okay, then the any points of minus 1 and 0 is symmetrical about the u axis. Okay, symmetrical about the u axis. Consider x plus y is equals to 1 or y is equals to 1 minus x. So equation 1 becomes u is equals to x square minus of 1 minus x to the whole square. Okay, so 1 minus u square is equals to 2v, or u square is equals to minus 2 into v minus of 1 by 2. This is also parabola in the w plane with vertex 0 comma 1 by 2 is symmetrical about v axis. Okay, the region as follows. Here also z plane and w plane. It's very simple type of problems, and similar problem you have to solve similar type of problems. Question number 3 is also similar is there. Okay, so w is equals to e raised to z, and by using some other cases, case 1 and case 2 is also used. Okay, so here also discussion of w is equals to z plus 1 by z. So z is not equals to 0, similarly w is equals to z plus 1 by z. So putting z is equals to r into e raised to I theta, we have u plus iv is equals to so real parts, substituting real and imaginary parts, r into e raised to I theta plus 1 by r into e raised to minus I theta minus I theta, u plus iv is equals to r of cos theta plus I sin theta plus 1 by r is take outside, cos theta minus I sin theta, u plus, that is u plus iv. So take 1 plus r plus 1 by r cos theta plus imaginary parts of r minus 1 by r is sin theta. So separating real and imaginary parts, u is take, and similarly v is also take. Okay, we shall eliminate r and theta separately from 1. To eliminate theta, let us put 1 in the polar form, u dividing by r plus 1 by r is equals to cos theta, and v dividing by r minus 1 by r is equals to sin theta. Squaring and adding we often. So u square dividing by r plus 1 by r to the whole square plus v square dividing by r minus 1 by r to the whole square is equals to 1, where r is not equals to 1. Okay, to eliminate r, let's put 1 in the form u by cos theta and v by sin theta, and real part r plus 1 by r minus 1 by r. Here squaring and subtracting we often, u square dividing by cos square theta minus v square dividing by sin square theta. Answer is 4. U square dividing by 2 cos theta to the whole square minus v square dividing by 2 sin theta to the whole square is equals to 1. Since z is equals to r into e raised to I theta, that is modulus of z is also r, and amplitude z is equals to theta. So modulus of z is equals to the formula square root of x square plus y square is r. So finally x square plus y square is equals to r square. So this represents a circle with center, origin and radius r in the z plane, where r is a constant. Amplitude z is equals to theta. So the formula of amplitude of z is equals to theta. So what is amplitude? So tan inverse of y by x is equals to theta. So y by x is equals to tan theta. So this is the this represents the straight line in the z plane. Okay, z plane when theta is a constant, by using some other cases, case 1 and case 2. Okay, case 1 and case 2. What is the final answer? Case 1, square root of a square minus b square is equals to square root of 4 is equals to, there are two values plus or minus 2. Okay, so here that the circle z is modulus of z is equals to r, constant in the z plane. Okay, then you have to take case 2. Let theta is equals to constant. Equation 3 is of the form u square dividing by a square minus v square dividing by b square is equals to 1, where a is equals to 2 cos theta and b is equals to 2 sin theta. So therefore w plane with foci of plus or minus square root of a square plus b square comma 0 is equals to plus or minus is 2 comma 0. So they are called the confocal conics. Okay, this is called the confocal conics. So this is related diagrams. So here also z plane and w plane you have to take, and some other related problems, question number 1 2. So you have to solve by homework only. Okay, question number 1 and 2. Question number 1 and 2, this also similar type of problems. Next next concept, bilinear transformation. Okay, bilinear transformation. The transformation w is equals to az plus b dividing by cz plus d, where a b c and d are real or complex constant, which is called as real or complex constant, such that ad minus bc is there. No, ad minus bc is not equals to 0, is called as the bilinear transformation. Okay, some other main points of bilinear transformation. So it is noted as BLT. Okay, bilinear transformation. So condition, first condition, AD minus BC is not equals to 0. Okay, is not equals to 0. We have by derivative of dw by dz is equals to cz plus d of a minus az plus b of c dividing by cz plus d to the whole square is equals to ad minus bc dividing by cz plus d to the whole square. Okay, finally, which implies that derivative of w is not equals to 0. Hence the transformation of conformal. Okay, hence it is transformation of conformal. Next second is the invariant points. Second one is invariant points. Okay, next this problem of working procedure. Step 1, let given w1 w2 and w3 corresponding to z1 z2 z3, we assume the bilinear transformation in the form w is equals to az plus b dividing by cz plus d. Okay, so by using some other steps 1 2 3 and 4 we will get. First second step, we substitute given set points, obtain the set 3 equations in 4 unknowns a b and c d. Okay, so in the third step we deduce a pair of equations in any 3 unknowns and solve by the rule of cross multiplication to obtain a what is that, proportionate set of values for the 3 unknowns, and similarly for step 4 and step 5. Then what? Next, worked problems. So worked problems is a similar type of problem is there. How to solve one by one. Okay, so find the bilinear transformation which map the points z is equals to 1 and I is equals to I and minus 1 into w is equals to I comma 0 and minus I. Under the transformation, find the images of modulus of z is less than 1. Okay, first you have to take solution. W is equals to az plus b dividing by cz plus d be the required bilinear transformation. We shall substitute the given values of z and w to obtain three equations as follows. First you have to take z is equals to 1, then w is equals to I, which gives I is equals to a plus b dividing by c plus d. A plus b minus ci minus di is 0. So z is equals to I, then w is equals to theta, which gives ai plus b dividing by ci plus d is 0. So what is the value of? So value is minus a plus b minus ci plus di is 0. So equation number, give equation number 1 and 2. Next, now adding from equation number 1 plus 3. So what is the value? B minus ci is 0. Okay, so I have to give equation number 4. Then we shall solve 2 and 4 by writing in the form of ia plus 1b plus 0c is 0. So 0a plus 1b minus ic is 0. Okay, applying the rule cross multiplication by using the cross multiplication method. Okay, so we have a by determinant of 1 0 1 minus I is equals to minus b dividing by I 0 0 minus I, c is equals to c dividing by I 1 and 0 and 1. So this is the cross multiplication method. So what is the value is where k is any constant. Okay, k is any constant. So take a is, what is that? A is equals to minus I into k, then b is equals to minus k and c is equals to ik. Substituting the equation number 1, substituting the values of 1. Okay, minus ik minus k plus k minus di is 0. So minus of di plus ik is equals to 0 or d is equals to minus k. So w is equals to minus k into I minus k I into dividing by I into k into z minus k. So minus k is take upside in the numerator, 1 plus iz. So dividing by minus k is also similar of 1 minus iz is directly minus k minus is cancelled. So what is that? So w is equals to 1 plus iz dividing by 1 minus iz is the required bilinear transformations. Okay, so this is the required bilinear transformation. And similarly how to solve second problem is also similar method. Okay, here also find the bilinear transformation which map the points z is equals to 1 I minus 1 into w is equals to 2 comma I comma minus 2. Okay, this also similar problem, so you have to solve the one by one at home only. Okay, these are all a similar type of problems. Okay, third problem is also similar. These are also similar type of problems. You solved one by one. So these are all assignment problems. Next, complex integration. So next concept is complex integration. So what is meant by complex integration? So take a let f of z be continuous function of the complex variable z is equals to x plus iy. Let's see be curve in the xy plane. The integral of f of z along the path c is called the complex line integral, usually denoted by integral of f of z by limits c only. Okay, with respect to z. If c is any simple closed curve, the notation of integral of c f of z into dz is also used. Okay, then properties of the complex integral. These are the some properties of the complex integrals. So integral of if minus c denotes the curve, transformed some other these points. Okay, and first point, second point, third point, this is the properties of the complex integral. And in the second line integral of complex valued functions, this is the line integral of complex valued functions. Integral of f of z with respect to z is equals to integral of what is f of z, u plus iv, and dz means with respect to x and with respect to y, right, imaginary parts only. Okay, so this is the line integral of complex valued functions. So then worked examples, this is the worked examples. Evaluate integral of z square with respect to z. Okay, with respect to z. So limit is c. So that is the first point. Along the straight line for z is equals to 0 or 2, z is equals to 3 plus I. Second, along the curve made up of two line segments, one from z, another from z is equals to 3 to z is equals to 3 plus I. Okay, what is the integral z square with respect to dz means integral of z is equals to 0 to 3 plus I, limits z square with respect to z. So here z varies from 0 to 3 plus I, means that so take the coordinates of x and y axis. This main point is b of the points 3 minus I, this is the point 3 minus this 3 minus I. Okay, so 3 minus I, so given by, so y minus 0 dividing by x minus 0 is equals to the value of y minus 1 minus 0 dividing by x means 3 minus 0. What is the value? Y is equals to x by 3. Further, z square is equal to x plus iy to the whole square. So this is the x minus x square minus y square of plus I into 2xy. Dx is equal, dz is equal to dx plus I dy. Substituting the values of z square, integral of z square with respect to dz. So x square minus y square plus imaginary 2xi with respect to x and with respect to y. What is the value? By using integral, by using integration, we have y is equals to x by 3 and or x is equals to 3y. We shall convert these integrals into the variable y and integrate with respect to y from 1 to 0 to 1. We also have with respect to dx means 3 into dy. Now let us consider integral of z square dz. Integration of y is equals to 0 to 1, 9y square minus y square 3 into dy minus 2 into 3y with respect to dy into y only, plus imaginary I into integral of limits y is equals to 0 to 1, 2 into 3y into y 3 into dy plus 9y square minus y square with respect to dy. So what is the answer? Separating some other points. Okay, so 18 is take outside. Integral of y square y cube by 3 by using the limits 0 to 1, and 26 I is take outside. What is the integral of y square y cube by 3 by using the limits 0 to 1? So is equals to 6 here. The value 6 plus 26 by 3 is I. Okay, so integral of z square by limits is c with respect to dz. Okay, is equals to 6 plus 26 I, 26 by 3 into I along the given path. So this is the main points of what is that? Evaluate z square, integral of z square. It is a very simple type of problems. Only you have to apply integral. Okay, integral method only, and these are also similar type of problems. Do it homework. Okay, these also similar. Evaluate z bar to the whole square is also similar. Okay, z bar means z plus I, like that only you have to use. Here also. Okay, these are all similar type of problems. Next, this is the Cauchy theorem. By using Cauchy theorem, you discussed in complex variables. Okay, Cauchy theorem. So if f of z is analytic at all points inside and on a simple closed curve C, then integral of f of z dz is equals to 0. F of z is equals to u plus iv. So like that only how to use. These are all main standard points of mdx ndi, like that only. Okay, this proves Cauchy theorem. Already solved. This type of problems is already solved. Okay, these are all worked problems. You should have to prepare properly. Okay, these are all assignment questions. Okay, this is the complex analysis of the conformal transformations. Okay, this is the topic of conformal transformations. Hello dear students, this is Mr. Manjunath Gowda, Assistant Professor, Department of